characteristics of homologous series. Now, all the members in the homologous series has four characteristics or four similarities. Okay, so we are going to discuss them one by one. Now, the first one, every member in the homologous series can be represented by a general formula. For example, alkane. Alkane, the general formula is CnH2n plus 2. Okay. Now, what does this mean? What does this mean? It means that the first member of this homologous series, alkane is a homologous series. The first members of the homologous series where n equals to 1, n equals to 1 is C. Now, n, this is 1, C1, H2. Now, 2n. So, n equals 1 and then plus 2. Okay. If the number of atoms is 1, we can ignore it. So, therefore, we do not write C1, but we just write C. Okay. And this one, 2 times 1 plus 2 is equal to 4. So, therefore, the molecular formula for the first alkane is CH4. Okay, so this is the general formula for all alkane, and this is the molecular formula for the first alkane. Okay, then how about the second alkane? Now for the second alkane, n equal to 2, and therefore the molecular formula will be C2, 2 because n equal to 2, n equal to 2, H2 multiplied by 2 plus 2, and this is equal to C2. H6. So this is the molecular formula for the second alkane. Okay, second alkane. How about n equal to 3? N equal to 3, then we have C3, H 2 times 3 plus 2, then the molecular formula is C3H8, and so on. So on. N equal to 4, n equal to 5, and n equal to 6, and so on. Okay. Each alkane has different molecular formula, CH4, C2H6, C3H8, but we have a general formula. This is the general formula. So this general formula, it represents the molecular formula for all the alkanes. Okay, all the alkanes. That is what does it mean by the general formula. Okay, so the general formula for alkane is CnH2n plus 2, where n equal to 1, 2, 3, and so on. Okay, the general formula for alkene is CnH2n only. And then n equal to 2, 3, 4, and so on. Okay, so you see, for alkane, the n start from 1, but for alkene, the n start from 2. And there's the reason for that, which we are going to discuss that later. Okay. The general formula for alcohol is CnH2n plus 1 OH. Okay, OH, and n start from 1. Okay. Okay. The general formula for carboxylic acid is CnH2n plus 1 COOH, and for this one, n start from 0, 0, 1, 2, and so on. Okay, and the last one, the general formula for ester, this one is a little bit complicated. Okay, the general formula is CnH2n plus 1 COO CmH2m plus 1. So the n start from 1. Okay, the m also start from 1. 1, 2, and 3, and so on. Okay, now you need to memorize the general formula for these 5 homologous series. You must memorize them. Okay, it's very, very important for you to memorize them. Okay, because without the general formula, it's very hard for you to write the molecular formula for all these carbon compounds. Okay, the second characteristics. Every member differ from others by the group CH2, which has a relative mass 14. Okay, for examples, let's see alkane. The first alkane is CH4 So the second alkane is C2H6. And from here we can see that the difference is 1 carbon and 2 hydrogens. Okay, and then the third alkane is C3H8. Okay, so the difference is also a CH2. And the fourth alkane C4H10, the difference is CH2. And the fifth alkane C5H12, the difference is also CH2. Okay, so this is the first 5 alkane, and we can see that the difference between one alkane with another is this CH2 groups. CH2 group, and then the relative mass of this CH2 group is 14 because carbons, the relative atomic mass is 12, and hydrogen, the relative atomic mass is 1. Okay, so 12 plus 2 times 1, so it's equal to 14. So each members in a homologous series differ from the next members by a relative mass of 14. Okay, characteristics of homologous series 3. Members of the homologous series have the same chemical properties. For example, all alkenes show addition reaction as added into bromines. Okay, so when alkene, let's say we have ethene, so ethenes, it can react with bromine, and then it will become the C2H4Br2. Okay, another alkene, propene, C3H6, it can also react with bromine. Okay, this is called addition reactions, which we will discuss later. Okay, so C3H6Br2. Okay, so the next alkene, C4H8. So what do you think? Do you think this is butene? Okay, do you think butene can react with bromine? Yes. Okay, why? Because they are in the same homologous series, and all the members in the same homologous series, they have similar chemical properties. So if this can react with bromine, this can also react with bromine, and therefore this must also be able to react with bromine. Okay, and then it will become C4H8Br2. Okay, Br2, and so on. Okay, C5H10, C6H12, all can react with bromine. Okay, so all the members in the homologous series, they have the same chemical properties. Characteristics of homologous series 4. Members of the same homologous series can be prepared through one common method. Okay, means that all the members in the same homologous series can be prepared by using the same methods. Okay, so for examples, all alkenes can be prepared by dehydrations of relevant alcohol. Okay, for examples, if you want to prepare ethene, okay, then we can use a method called dehydrations of ethanol. Okay, so if we want to prepare propene, another alkene, okay, we can use the same methods. So we use dehydrations of, but these times we do not use ethanol. Okay, because they must use the relevant alcohol. These times we use propanol. Okay, if we want to produce butene, okay, then we can use dehydrations of butanol. And if we want to prepare pentene, okay, then we can use dehydrations of pentanol, and so on. Okay, so means that all the members in this homologous series can be prepared by using the same method, which is dehydrations of alcohol. The only difference is we use different alcohol to get different alkenes.